Hi, I am Alper Özdemir and I am a freshman electrical and electronics engineering student at Bilkent University. I am taking Physics 101 in Section 8 and my ID number is 22101860. In this video, I will be presenting my project for Physics 101, which is called the relation between the mass and the descent time of an object on an inclined plane. My aim was to discover the relationship between the mass of an object and the time taken by this object to reach ground level when it is released from a certain height on an inclined and frictional plane. Considering the free body diagram of an object moving on an inclined plane, the expression of its acceleration is the formula shown if air friction is neglected. I identified this expression does not involve the mass of the object. So the descent time should be independent of the mass of the object and should be equal for objects of different masses. The equipment used in this experiment is an inclined plane, two objects of different masses, slow motion camera, and covering material. In order to keep the coefficient of kinetic friction to be the same for both cases, I covered the undersurface of both objects with the same material. I released objects from the same height on the same inclined plane respectively and recorded in slow motion in order to obtain the time taken by the objects to reach ground level. I repeated this process 5 times for each object. I obtained the shown data. Theoretically, the difference between delta t values should be equal to 0, since they are expected to be equal to each other. The error values are shown. These error values appeared because I neglected the air friction, but this force has affected the values. Moreover, the coefficient of kinetic friction may not be constant, because the surface of the inclined plane wasn't completely homogeneous. Also, the objects rotated a little while they were descending, therefore delta t values have been affected. Furthermore, I have obtained delta t values from the slow motion records, so I may have calculated these values incorrectly, because it was hard to distinguish at what time does the object start moving. At the end, I wanted to show that descent time of the objects does not depend on their masses. Although the time values are not found to be equal to each other due to the errors in my experiment setup, they were close to each other, so mass of the objects do not actually affect the sliding time. Thank you for watching my video.